you say that today was for review?
Yeah. So I'm going to give a review. So you can ask questions. What is up?
For these ones, do you want us to just use like the X and the Y?
Yeah. All right, so we'll do our midterm review today. So I'm just trying to put up a question to get us started. So basically how we'll do the review, at least in general, is I'll kind of go through the exam and kind of give sample questions and kind of talk about stuff so you feel good about it. And so your exam ended up being, let's see, the total count is 13 questions. Some of those have some parts though. So not too bad, and it is all open note for y'all. So this is only for my Chem 100 level series, so open everything so you can use all your notes. Just know, right, Googling for the exact resource. But, you know, textbooks, notes, old homeworks, everything is on the table. And then it shouldn't be time intensive. I designed the exam to be done in like, I said 1.5 hours so that you have like leeway, so with the 2 hours. So I don't think time will be an issue, and if you do have an accommodation or something, you can just like stay longer for the time. And then I would have to check back, I don't remember all my accommodations, but if anyone like has special testing things, like you have to test quietly, separately, whatever, just let me know, because otherwise you'll have to do that separately. And I was just planning on testing everybody here. And yes, so midterm is open notes, so that was just in the chat. So yes, open notes, just do not ask your neighbor and do not ask Google. Those are the only rules. All right, let's see if we can classify. So this is similar to the first question on your exam. And so let's see if you can identify these as elements, compounds, or mixtures. All right, so start off with those first few examples. So just reminding ourselves how to classify elements. Also, if you didn't get your chapter 3 homework back, aka there's no grade in the grade book, then that might be yours. Do we have answers? Do we need more time? So what do we get for the first one? C60. Element. Excellent. And chat agrees. And so, right, don't forget all your diatomics as well. I don't think that has been too much of an issue for this class, but right, anytime we write, nitrogen, oxygen, especially as we start getting into the chemical reactions, right, we're talking about adding things, like we want to say, oh, we add hydrogen and nitrogen, make sure that they are in their elemental diatomic form. So, excellent. And so what's methane? Compound. Excellent. So that one you had to know that methane is CH4. And then what about cheese? What do we get for cheese? Mixture, is it homogeneous or heterogeneous? So homogeneous, and this could be one, again, on an exam where you could clarify, right, like it's homogeneous, especially if it's like cheddar cheese. I don't know how to spell cheddar. But, right, maybe you were thinking, well, what if it was jalapeno or Swiss, right? Then you could have clarified on your exam, well, I'm thinking about Swiss and jalapeno cheese, right? And so that would be heterogeneous. And so again, right, just clarify on your exam if you're not sure of something. Someone, had brought up like that they didn't know what aspirin was. And so if you came up with that on an exam, right, just kind of write, if I'm assuming, aspirin is a discrete molecule, then it would be a compound type of thing. So that's what I'm asking for. Or, because I'm not going to ask this because I don't want to like get people all confused, but like Alka-Seltzer, like that's a mixture, but then you have to know that it's a mixture of like different chemical compounds. So that's where on an exam, if you were confused, you could always write like, I'm not sure what Alka-Seltzer is, but I think I picked simple enough stuff that hopefully that won't be an issue. But again, just write, little clarifying notes to me if it does. What about this one, C21H30O2? So compound, doesn't matter what it is, just as long as we have our chemical formula. And then what about our Java chip Frappuccino? Yeah, and then heterogeneous, so make sure. Excellent. All right, so let's do another one. And so next on your exam, right, there's going to be some sort of conversions. And I may ask you to convert things that like aren't real. So that could happen. And so let's see how that might look. So let's go convert 467,000. Let's do kilo goops to floof if there are 19.5 goops in a floof. Let's see if we can do that conversion. Oh. Oh, maybe yours is just hiding somewhere. Let me see if I pass it back. How did I put your grade in? Because now I remember seeing your paper. Yeah, I could have skipped it.
Okay.
Yeah, so I guess I somehow didn't enter yours. Let me do that. Which happens.
Well, I was like, that doesn't look like mine, but awesome.
Yeah, that's good.
But I found a name for you. Also,
Yeah,
so.
Thanks.
Yeah. Am I your pen? Okay.
Oh, I think I confused your dots. I wasn't having it, I thought this was like an electron.
Oh,
So I got
like
confused.
the
Yeah.
second document.
Yeah. Yeah, it doesn't matter. Yeah, so that was mine.
Okay.
Bad.
Cool.
And then just double check your grades that everything made it into Blackboard correctly.
So who's doing this from your times? Do you add these together and then divide by 2?
No, you multiply it, yeah.
And then just add or them
Yeah.
together?
Yeah, we'll probably go over that though.
Okay. Because I guess I was not understanding. So you will go over it or
Yeah.
ask afterwards?
All right, how did our conversion go, or how is it going? Do we have an answer, an approach at least? Does someone want to at least kind of walk us through the setup? So we're trying to go kilogoops to floof. So what do we do? And then, so then you set up your conversion factor. So the only thing is, what do you do about this kilo? Yeah, so right, did anybody hear that? So let's go from kilogoops to goops first, right? So that we can set up our conversion factor. And so kilo is just our usual conversion. So right, we have, so one kilogoop is equal to, right, 1,000 goops. So we can set that up. And then you said, okay, let's set up our next conversion factor. So we can just write this as a fraction, right? So we have 19.5 goops in a floof. And okay, so we're trying to get floofs on top. So 1 floof over 19.5. So does that look about right? Well, yeah, I don't know if goop is a real unit, but yeah. So on the exam, I'm just going to give you some like made up units. So. Oh, because some people were in the chat were trying to figure out what a goop was. I guess it's like a real unit of signal strength, but I just made up stuff. And so then, right, plug this into the calculator. Chat has an answer, but let me confirm. / you guys can yell at me what y'all got. 2, 3, 4. Is this what y'all got for your answer? I feel like I messed up somewhere. All right, so that looks good. So let's see, where are we at? 1, 2, 3, 4, 5, 6, 7. And so we only have 3 sig figs. So 2.40 times 10 to the 7th. Oops. Any questions about that one? We could do another conversion, just practicing. How are we feeling? Do we need more conversions? Let's do one more. Let's do so convert 7.77 times 10 to the negative 11th megameters to picometers. So how are we doing on this one? So how do we approach this problem? Yeah. So you just try to find the direct conversion factor between them. So that would be the one-step approach, right? So mega is 10 to the 6, pico is 10 to the negative 12. So there, right, subtracting them, so dividing, so 10 to the 6 divided by 10 to the 12, so 6 minus a minus 12 gives you that 10 to the 18. So that's one way to do it. So that would work. And then really you can just add your exponents, so 18 plus negative 11 does give you the answer. But let's go ahead and just do the two-step conversion for people. So we have, so again, right, we can do our megameter first. So starting off with our conversion factor, so 1 megameter is 1 times 10 to the 6 meters. All right, so now we're at meters, so we need picometers. So 1 times 10 to the 12 picometers are in 1 meter. So now that cancels, And so notice, right, we get our 10 to the 18th factor back out like you could have gotten through the other method. So again, just kind of reaffirming either method. And so we could do mental math of adding our exponents. So negative 11 plus 6 plus 12. So then that gives us 7.77 times 10 to the 7th picometers. And of course, you can plug it into the calculator. But it's always good to kind of check yourself, you know, with sanity, with adding the exponents and everything, doing a little mental math, because you never know how you could screw up a calculator. So it's always good that you can sanity check yourself. And so we got the same answer, so 1, 2, 3, 4, 5, 6, 7. Questions on this one? So let's look at our next type of problem. So we talked about periodic trends. So now let's practice. So which has the largest radius? So we're looking at phosphorus or chlorine. And then which one of those has the highest ionization? So what do you think about those? Yeah,
Phosphorus has the larger radius and chlorine has the higher energy.
so do we all agree with that? All right, so excellent. So we said, so let's slow that down for a second. So phosphorus, larger radius. And so why is that? We just need a small explanation.
Because the energy increases as it goes to the left of the periodic table and decreases while it goes to the right.
And then, but radius though?
Sorry, radius. Radius increases to the left while the energy increases to the right.
Yeah, wait, now I got myself confused.
Sorry if I messed you up there.
So radius increases, you said to the left, right? Okay, yes, yes. So radius, right, is, I always like to think it as decreasing as you go right from left to right, so bigger radius on our left side of the periodic table. So yes, phosphorus has the larger radius. And I think you said the answer, but then who has the highest ionization energy? So chlorine.
Because the energy increases when it goes to the right.
Yes. And so you could answer that just by periodic trends, but I do want to emphasize, right, that we want to think about the electrons and how they're filled up. So looking at phosphorus with its 3p, right? So we're just thinking about, okay, those electrons, right, are being filled in. And so comparing them, because again, we're saying this is what we're arguing with the trends. It's just good to see it. And so, right, comparing the electronic structure, well, we can say, well, phosphorus has a larger radius since chlorine, right, has more electrons on the same energy level. So that's going to make that radius smaller comparatively. So again, that's why our radius decreases as we go across the periodic table from left to right. And then that same argument can be used for this higher ionization energy argument. So again, follows the trend. We can also see, okay, well, chlorine is pretty close to filled octet, so it's going to be really unhappy to give up off an electron compared to phosphorus. And phosphorus will still be, unhappy about it, but again, as we get closer and closer to filling the octet rule, then that's going to lead to increased ionization energy. All right. Questions about this? Feeling okay? All right, so let's do a little practice on temperature conversions. And so for temperature conversions, again, just kind of watch the formula. So you will be given a different formula on your exam, so I don't want to give too much away. So just plug it in, but let's just do a practice one. So convert 333 degrees Fahrenheit to Celsius, and again, I'm going to provide you with a formula. This will not be the one you'll be provided with, but again, I don't want to give the entire exam away. So what did we get for this one? Y'all can yell at me. Yep, so 167 degrees Celsius. So again, that's just plugging it in. So show your work on an exam, again, just in case something goes wrong with the calculator punching. I see plenty of people flipping numbers and all sorts of crazy things, so just show your work. And again, right on the exam, you'll be given a different formula, so just follow that formula. Let's do another one from your exam. So let me write it out. So a sheet of particle board is cut to a length of 6 feet and a width of 3.5 feet and weighs 60.0 pounds. So given the density is 53.7 pounds per feet cubed, what is the thickness of the board? Think about how you would approach that problem. Kind of think about what we've done in lab. So how's the problem going? Any thoughts on it? What information do we have? we've got length, we've got width, we've got mass, we've got density. So what can we do with this known information? What formulas come to mind or anything? Yeah, so then we can think of, okay, well, density is mass over volume. Yep, so we have density, we have mass, and then, right, we have two sides for our volume, right? So now we're kind of thinking about what this is really asking, right? So then that's kind of the question is, right, how do you think about stuff? So that's the fun part of this. So, right, you're trying to puzzle out, okay, what is it asking? So then, right, draw yourself a little visual. Okay, we have our particle board sheet. So we have a length that's 6, right? We have another one that's 3.5 feet. And then, okay, we're just trying to find that little thickness here, our height, right? So you can even write length times width times height equals our volume. And so now we're ready to solve, essentially. So yeah, make sure you set it up that it's length times width times height. So then, right, you just have to plug in 3.5 times 6 times x is equal to your volume. And so now we can go back and solve for volume based off of this formula. So we have 53.7 pounds per feet cubed. And so I want to get to volume. Oh, set it up wrong. I'm going to do mass divided by density. So 53.7 pounds feet cubed. So then we should get that something for this, for the volume. So our volume, oops, is 1.12, right, feet cubed, which is equal to, we said it was equal to this, so we already set that up. So then divided by 3.5, divided by 6. And so we should get a height of 0.053 feet. And then, well, I didn't ask for it in inches, but watch for that on the exam. So you might have to convert from feet to inches. So of course you can just multiply that by 12. Times 12, or 0.638 inches. Does that make sense? All right, let's do some other ones. Let's do, so write the electron configuration and Lewis dot structure for the following. So the first one is antimony. And then let's also do sulfur 2- and tin 2 plus. How are our electron configurations moving? Do we have the first one?
Krypton,
5s2, 4010, 5p3. Excellent. And then antimony, doesn't matter where you put the 2 dots, but then make sure you have the 3 dots separately. Yeah. No, so you could put them, yeah, like there, or, yeah, it doesn't matter. Correct, yeah, just as long as they're on like the appropriate like numbers on each side, right? Like for helium, right? Like don't do that. Put the same dots, put them on the same side to show that they're in like the s orbital together. But yeah, otherwise it doesn't matter like where they are. And then what do we get for sulfur's electron configuration? Sulfur 2 minus. Yeah, Brandon?
On my neon 3s2 3p4.
3p. So it'd be 3p4 for the neutral, right?
Also 3p6.
Yeah. So I'll put neutral. And then, yeah, so if you ever get confused on these two, right, start with the neutral, okay. It was 3p4, but then we have 2 minus, we know, all right, we need to add 2 more electrons there. And then this should make sense, right, sanity check, okay. Sulfur likes to be -2, so yes, it should probably be a noble gas configuration. And then what do we get for tin 2 plus?
orbitals if it's.
Nope, that's correct. Yeah. So right, so you could think about it. So again, right, the neutral would have filled up. So krypton, 5s2, 4d10, and then it's 5p2. Sorry, let me pull up a periodic table. All right, and we can kind of make sense of that. So right, look at 10, okay, it's over 1, 2. So there's our 5p2, and then again, right, if we're doing 10, 2 plus, then those are the electrons that are going to leave first. And so right, they're gone here. And then what's kind of interesting is this gives you a little hint as to why 10 is one of those funny ones with variable oxidation states. So right, we said it can go 10, 2 plus and 10, 4 plus. So if it lost these electrons on the s orbital, then that would be 10, 4 plus. And then, oh, I forgot to do electron configurations for these. So sulfur should have all the electrons around it now. And then you want to put a -2 charge on there, just showing like, yes, it has 2 extra electrons, right, from the neutral. And so same thing for 10. So I'm just going to draw 2 dots, doesn't matter what side. And then, right, draw a little 2 plus on there, showing that it lost 2 electrons. All right, let's probably take a little 10-minute break. So we'll be back here at like 2 or so, or a little after, and we'll keep doing some more problems.
Available after school today?
Yeah.
I did. I had kind of want to try to finish my chapter 4 homework in my lab so I can focus tomorrow on reviewing for the midterm. That's okay with you?
Yeah, that sounds good.
So 2 being, or 10 being a plus 2, do those 2 electrons have to be paired up next to each other if it's just the 2 of them, or can it be separate?
I prefer that those 2 electrons are together because we're basing it off of the electron configuration that's reflected of that 5s2, where both of them are in that s orbital. Yeah. But that's like, again, the more complicated way of looking at it. That's why in like high school you do more like simplified rules and end up with like the magnesium with, you know, dot on each side. Yeah, we're trying to look at the orbitals at least a little bit and then have our Lewis dot structure reflect it. it?
I don't have any quiz grades.
Oh, that's weird.
This is my first two, and I think I took the third one the other week. I don't have the third one.
But the third one you
Did I
just
do that
took right
today?
now.
Okay,
Yeah, 'cause I haven't
alright.
graded
I
that
can't
one.
remember which is which anymore.
Yeah, let me fix this.
Is the welcome quiz one of those two?
No, the welcome quiz was another one.
I don't know what I'm missing in there, to be honest.
Oh, this is weird. Okay. Now I'm even more confused. It says you don't have a grade. What did I do? So there, what does your Blackboard show? Because I have grades for you. I just think there's something funny. Okay, I think it's me, but I need to fix it, and I'm not sure how. Because I think it has the quizzes as like not appearing.
Because I compared it to the one in my house too, because I got it on my computer and it looked the same. So I didn't know if I was just nuts.
Yeah, I'll. Yeah. Also, just a note, so somebody just brought up something with Blackboard, and I don't know how to fix it, just looking at it. So the problem, something went funny with Blackboard, because we're on Blackboard Ultra. And so how I always do it in the past, because I've run this class multiple times, and I copy the same shell, but when I teach it online, I obviously have all your same assignments, but they're online. I much prefer paper. Now, for some reason, Blackboard, because I've hidden the online quiz from y'all, because I don't want you taking the online quiz, now it's like not posting your quiz grades, I think. So I don't know how to fix that right now, because I don't obviously want to open the quiz, because that would be a disaster, and this hasn't been a problem. So I apologize. I will try to figure out what's going on. Worst case, I may have to rebuild this whole grade book. Yeah. I will keep accurate records, though, of your grades. But yeah, I apologize for that. I don't know how to fix it at the moment. It's not the greatest, so you probably want to double check that I've not messed up your quizzes. All right, do we have an answer for this one? Do we need more time? So how many protons do we get? What did you say? 135, and chat agrees with that. And then how many neutrons? So 153, so you just had to take right 288 minus 135. And then what do we get for electrons? Remember it said 4 plus charge. So 131 electrons. And I see that on the chat. So let's do some naming practice. So how I kind of worded it is it says give the chemical formula and name of a compound formed from the following pairs. Of elements or polyatomics. So this is how it's phrased on your exam. And so again, just to give you an idea of how this would look. So then our pairs would be like chromium 3 and phosphorus. So what compound does that make? Name it properly. And ammonium and sulfur. So silver and phosphate. And we'll do tungsten. And I'll add one more. So phosphorus and sulfur. Same two. And then this last one, again, is just practicing the wording on the exam. So it says phosphorus and sulfur. And then note that it does tell you that you have to assume 2 atoms of phosphorus and 3 of sulfur. So that's how a question would be worded. So see if you can figure those compounds out and the formulas. So you want to give the name and the proper formula for this one. Chromium 3. Do you still need more time? Okay, let's start hearing what we got for these. So what did we get for both the name and the formula for this chromium-3 and phosphorus? So what compound does that make? So let's see. So we want to put the chromium first, though. But then, so what's the oxidation state of chromium here? So +3, right? But then what? And what's phosphorus? -3, right? So they're already balanced. We could just do Cr. Oh yeah, P. I don't know. And so then, how do we name that properly? Yeah, and then don't forget the 3 though, so chromium 3 phosphide. Right? And then let's do this next one, ammonium and sulfur. What do we get for that one? Well, so we have NH4 and then So what's the charge on sulfur? It should be -2, right, for the oxidation state. So then how many ammoniums do we need? So 2, and then it's just sulfur. Then how do we name it? And then you just say ammonium though. So ammonium, yeah, so we don't need to use prefixes. Since we know ammonium's, right, always going to be NH4 1+, we know that from our polyatomics. Sulfur, again, is always 2-. Okay. What about silver and phosphate? What does that make? Yeah, what'd you get, Crystal? You want to write it where the cation is first, so it's always cation, anion. So Ag, but then, so we need to balance it. So what's the oxidation state of silver? And then what, phosphate, what's the charge on phosphate? It should be -3 from your polyatomics, because you have to look at phosphate. So then what subscript do I need? Three. Yeah, so 3, so right, we need 3 silvers to balance out our phosphate. And then how do we name this one? Silver phosphate, yeah. And what about this one? Tungsten, 3, and oxygen. You put, what'd you say, W? So double check that, right? If tungsten is 3.
That's a 3, so.
Oh. So do we, what number should there be? Isaiah, what'd you get? W203. That looks good. And then how do we name this? Yeah, tungsten 3 oxide.
And how did you get the oxygen? I can't say that word, but tungsten.
So this one, we just had to go off of the little 3 here. Yeah, so for all these metals on your exam, if you have a multivalent metal, right, I have to tell you the oxidation state. So yeah, that little Roman numeral. And then, of course, oxygen, right, -2. Again, make sure you have your periodic table all labeled. And then this last one, so again, right, this is kind of funny wording, but that is just how it's going to be on the exam, how I try to phrase these questions. So what do we get for this one? Yep, so right, that's the point, yeah. So it's a covalent compound, so I have to kind of give it to you since we, right, we don't know the ratios, could be any ratios, just like N and O. And, right, so you could also recognize, okay, well, this is a covalent compound because, again, I had to tell you how many. And then how do we name it then? Trisulfide, yeah, you had it the first time. Excellent. So diphosphorus trisulfide.
So the prefixes on the first element come when it's a covalent bond.
Yeah, and only when it's not like 1. So, right, if it had just been like PS3, then it would have just been phosphorus trisulfide. We don't say like mono, but. So this would be phosphorus. And then, of course, if we had done some combination with P and S, right, then you just say the mono for the second one. So phosphorus monosulfide. Yeah.
Sorry for the stupid question, but
So for acids, you just kind of have to like remember them, unfortunately, because like right, they all do some sort of hydro, at least for a lot of them, right? Like we saw hydrochloric acid, so HCl, hydrobromic. So those simple ones follow that pattern, but then you have like the weird ones like nitric acid that again you just kind of end up remembering, and phosphoric acid. You could do carbonic acid. All right, let's look at one of your isotope questions. Oh, yeah. Sorry. So I'm pulling up your lab. All right, so let's re-review this, and then we'll talk about a slightly different scenario. If I can find it. Oh, wrong lab. Lab 3 is what I'm trying to find. There we go. So lab 3 is where, right, we had these isotope abundance things. So adding them up. So I just kind of wanted to re-review this because people were still having issues. So I'm just going to copy this problem. And so again, right, we're just trying to emphasize, so the whole point of doing this like abundance thing, and what I see people doing is, right, a lot of people are just trying to add up all of these, right, and take the average. But that would be like assuming, right, so if we add an average, right, then that's the same thing as saying that they all have a 25% abundance. But that's not true, right? So does that kind of make sense what we're saying mathematically when we just average this? And so we can't just do that, right? And so that's why we have to go through this process. And so what we have to do is multiply it by our appropriate percent abundance, right, to give us the weighting. Because this essentially, right, gives us the weighting, right? And how much that mass is important to the average. Again, right, think back to carbon where it has 99% of carbon-12, so that's why the mass is basically 12. And so again, mathematically, just multiply, so don't forget that you have to move the decimal over twice. So that was the only other area where people could have gotten tripped up here. And then the other thing that I was trying to get people to do is that, remember, you have to be consistent with your sig figs at each step. So that's kind of confusing. And so what I mean by that is, right, we want to do our sig figs with our multiplication. So we only have 2 sig figs in that first one, which does kind of limit our answer accuracy. So I can only report this to 2, so 2.9. And then again, add up the rest. So I'm just kind of showing you. And again, right, you want to do it step by step, so 49.6 6. So 45.7. And then so times 0.523. And then again, 3 sig figs. So that messes those up there. So then this one is a little weird, right? Because if we follow our sig fig rules, with our last one, we cannot add, we cannot report to any numbers after the decimal. So then we can add now. Plus 45.7. All right, so that's, so now we just get 207 AMU. All right, so we've done that before, but your exam has a slightly different scenario. And so let's look at a similar one. We'll kind of go through the trick together. And so now we're looking at, so we have to look at a specific scenario for this algebra to work out. So basically we're focusing on 2 isotopes. So in this case, we're going to look at gallium. So gallium has 2 isotopes. And the average atomic mass is 69.723 AMU. And then I need to give you their 2 isotopes. So we have gallium-69, which has a molecular weight of 68.9255 AMU. And then gallium-71, which is 70.9247 atomic mass units. And so now the question asks, okay, well, what is the percent abundance of each? So kind of think for a second, maybe how would you approach this? And then I'll give away the secret shortly if you can't figure out the trick. Uh, 9247. So I'll give the trick. And so the trick is, again, you have 2 isotopes. And so that means that, well, whatever my abundance is, so let's just call this X and let's call this Y. And again, it works because there's only 2 of them, right? Otherwise, we can't do this. But we can set up, well, X plus Y is equal to 100%, which is really, right, X plus Y is 1, because we want it in the decimal format. And then, well, if we want to get this to some sort of algebra thing that we could solve, well, we need to get rid of one of these variables. So, of course, y just becomes 1 minus x. And so now from here, it is just algebra. So then you end up, I'll show the setup, and then I'll let you guys play with the algebra. So then you have 68.9255 times x, and again, just watch your variables. And so now we're just adding, right, we're just plugging it into our isotopic formula, adding them up. And so this would be times 1 minus x is equal to our average atomic mass to that 69.723. So this is the setup and the hard part. And then from there, it's just algebra. So go ahead and see if you can solve that. Oh, sorry. Do we get an answer? Do we get an answer? Working on it. You got an answer back there? Yep. So, do people want me to go through the algebra? So, right, just start by distributing. So, plus 70.9247 minus 70.9247x. And so now, putting the variables together. Oops. So let me do this 68. .9255, so minus our 70.9247. So now we have like negative 1.992. X is equal to, so now I'm just trying to move the numbers over. So let's see, that gives us 69.723 minus my 70 over here. So then I have negative 1.2017 is equal to this negative 1.99x, so now divide. And so that's how you get x of 60%, so 0.6. Yeah, so 0.60. About 60%, and then you just do 1 minus your 60 to get your y. Questions on that one? So let's practice something. Let's draw a Lewis dot structure. And let's draw it, though, for nitrate. So see if you can draw out a structure. Remember what to do with the little negative charge. All right, for the sake of time, I'm just going to keep it moving here. So for these structures, the most important thing is getting our valence electron count. So we know nitrogen brings 5. We have each oxygen bringing 6. So 3, so 18. And then our negative charge, so that means we have an extra electron. So I just like to put my charge there. And so, okay, I know that means to add it, or add an electron. So if it was positive, right, you take away an electron. So now we have 24 total for our count. And so that means, right, in our structure, we need to have 24 electrons shown. And so then we can start kind of at least trying to piece it together. So I'm just starting off by drawing, right, a line to each oxygen. I don't really know what it looks like. And so doing a little mental math though. So 24, so 24 divided by 3 gives you what? 8. And so, right, just thinking about that, okay, that's the simplest solution, right? Have 8 on these oxygens here centered. So, right, 1, 2, 3, 4, 5, 6, 7, 8. So there we have it on each one. So there's our 24 electrons. And so now we can analyze this structure, right? Is it a good structure? Is anything wrong with it? So what's odd about it right now as it's drawn? So nitrogen doesn't meet the octet rule. And so right, even though we started here, now the next thing we want to do is probably make a double bond then to one of our structures. And so it doesn't matter which one. And so now we should still have 24 electrons, right? So we just move those. So this is 8, 16, and 17, 18, 19, 20, 21, 22, 23, 24. So this is the better structure. And then for completion's sake, we should add formal charges. And so we could go through the formal charges, how I calculated that. So remember, the formal charge formula is valence electrons from the periodic table minus the bonds minus each electron. So for oxygen, right, it's 6 minus 1 minus 1, 2, 3, 4, 5, 6. So that gives us a -1. This is the same. And then nitrogen is 5 minus 4, so that gives us our +1. And then the other thing is, so the charges should add up to the overall charge of our molecule. And so yes, right, these two cancel out, leaving us with a -1 overall charge. And then you wouldn't want to go adding another bond, right, and do anything. Because you could think about, well, could I eliminate this formal charge by making another double bond? But not for nitrogen, right? So if this was maybe phosphorus, that would be maybe a more appropriate resonance structure, because we said that phosphorus, right, is large enough to hang on to all those electrons, but nitrogen is not. So this would be our structure. And so notice we can make resonance structures, and all that means is that it doesn't really matter where we put our double bond. We can just rotate it around. So our structure is just the average of kind of all these structures. We could do that. And you can kind of figure out an average bond too. So we have 1, 2, 3, 4 bonds divided by 3 substituents. So everything is like 4 1/3 bond roughly lengthwise. Again, that's just roughly speaking. You would have to do solid state crystal structures to confirm that. So resonance structures. And then what would the geometry be of this then? Yeah, check your chart, right? It's got 3 things on it. Trigonal, and then what's the what? Yeah, so this would be trigonal planar, right? So it's got no electron groups on the center, just 3 atoms. And so, yes, trigonal planar. So that also tells you again how it behaves. And then, is this polar or nonpolar? Double check it. Yeah, nonpolar, because remember it's fully symmetric. And if you didn't grab one of these Vesper thingies, grab one. And so remember what we said, as long as it matches with the first one, right, that's always a fully symmetric combination. So for 3 electron pairs, right, we look, okay, it has to have 3 atoms. So yes, fully symmetric, right? If we went over to SO2, something with a bent, then it's not, so then it'd be polar. So that helps you. So trigonal planar, nonpolar. Maren, did you have a question?
Yeah, I was just wondering, when you're like calculating about other electrons you have to do, where'd you get the 1 from?
Oh, the 1 just came from this negative charge. Because, yeah, we didn't do too much of this practice, but when you have a polyatomic, you just have to account for the charge. And so I think we had done it in class, because remember we had done ammonium, and that was a plus charge, so we like took away an electron. And so this one, yeah, the negative, we added 1. And if it was -2, right, you had 2 electrons, -3, like phosphate has 3 extra. All right, and then in the last minute, so the other thing that is on your exam that we didn't like cover would just be like molecular weights of compounds, or like percent of mixtures, like kind of like the sand and salt from labs, so that sort of idea, what percent of a whole type of thing. We could do one of those practice problems, it's just right now we are at the bell, so I at least wanted to give people the idea of what's on the exam. All right, so yeah, we are probably officially done. I did go over every question though, so basically if you can do the review, you could do the exam. So right, just review what that entails, and you should be in good shape. I'll post these notes hopefully after class right now. And then I have office hours, so if you want to keep asking me questions, we can do that today. All right. So yeah, you're free to leave then. Otherwise, I will see you Wednesday for the exam. And then any last online questions before I end the stream? Now make sure you got all your homework back from me. I should have handed back everything. And then, yeah. Question?
How do you know like how to draw it like that? Like why wouldn't you just like draw it like in a different shape?
Like, I guess, what do you, because I kind of try to walk us through, because this is like just the most obvious thing where you just like stick a line to each one. But then we saw, okay, it doesn't follow the octet rule, so that's how we ended up with the double bonded structure. Yeah, I guess I'm not really sure like what other permutations were you trying to do.
Like would you be able to like do it like instead of like coming out from an angle, would you be able to do like from the side and from the top, or do you have to do it like?
Oh yeah, so that angle like doesn't matter so much, and then you'll see that, right, ultimately we're trying to get to that trigonal planar that are like bigger matches that. It's just like when you're sketching it out, right, it's not like always obvious. So you can just start by drawing out lines and then kind of look at this and, oh, okay, that's the shape.
Okay. And then, so like when you know it's non-polar, or I have to go back to.
Oh, sorry. You too. You're on a time crunch. And then, I can get you started.
So when you know it's like non-polar or polar, so like that would be non-polar.
Yeah, as long
because
as
it's-
all of these are the same, like even if they're all chlorine, 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 then it's non-polar. And then it only gets weird if it's like hydrogen, chlorine, chlorine, then they're different so that it's not symmetric.
Okay, so if they're all the same, like around of the same element, then it's not polar.
Correct.
But if you have like one element or more that is different, then it is polar.
Usually, yeah.
Okay.
Because I probably wouldn't, because it would only get like tricky if I gave you something like weird, like BF, CL, VR, right? Because then you're like, oh, are they really like that different since these are all very electronegative?
Uh-huh.
But I wouldn't give you something like that. I mean, I'd still probably consider this non-polar anyways,
Okay.
just because they're really close.
Yeah.
But yeah,
Okay.
I'll be more obvious. Where like, yes, it's an H and a chlorine, chlorine, so that's polar versus 3 of them.
Then it's not polar because they're
Yeah.
all the same.
Yeah.
Okay. Thank you.
Sorry, I have a question on this one. How are you finding, like,
Yeah, you're writing like that.
okay,
Yeah.
so like balance?
Yeah.
So would this one be correct?
Yeah.
I'm just confused. It's kind of just like the same thing every time to me, but how'd you get rid of the like? Not that, it's on the computer. That's why. Like how'd you get to there from the original? I'll grab my computer. 'Cause